June 2, 2024. A Long March 5 rocket tears a hole in the night sky above Wencheng, Hainan Island. The payload is Chang'e 6, and for the next 53 days the entire world, whether it admits it or not, is quietly holding its breath. Because this is not just another moon mission. This is the first time any nation has ever attempted to land on the far side of the moon, scoop up its ancient soil, and bring it home. No human eye has ever directly seen the landing zone in real time. No direct radio link exists. Every command, every camera frame, every heartbeat of data has to bounce off a relay satellite called chang'e 2 that sits 65,000 kilometers behind the moon in a halo orbit around the Earth-Moon L2 point. It is the loneliest mailbox in the solar system. And yet, at 22:23 UTC on June 1st, the lander's engines fire for the final 11 minutes of powered descent. Hazard avoidance cameras flick across a landscape never photographed in high resolution from the surface. The ground rushes up, gray, cratered, alien. Thrusters kick up a storm of dust that hangs in the vacuum like slow-motion smoke. Then silence. 4 landing legs settle into regolith that has not felt a touch in 4 billion years. Beijing control room erupts. China has just become the first country to soft land on the far side of the moon, twice. Chang'e 4 did it in 2019, but that was a technology demonstration. This time they came for the rocks. The target is a place called Apollo Basin, nested inside the South Pole-Aitken Basin, the largest, deepest, oldest impact scar in the entire solar system. Imagine a crater 2,500 kilometers wide and 13 kilometers deep, so big it would swallow Texas and still have room for dessert. It formed when something the size of a small planet slammed into the moon 4.1 billion years ago, an impact so violent it may have punched clean through the crust and exposed the mantle underneath. That single cataclysm is one of the main reasons the far side looks the way it does. High, rugged, almost no dark Maria, because the crust there is 30 to 50 kilometers thicker than on the near side, and the mantle below is colder, poorer in heat-producing elements. Or at least that was the textbook story, until Chang'e 6 started sending home its first close-up pictures. For 48 precious hours the lander is alive and busy. A robotic arm unfolds like a praying mantis and begins scooping surface regolith into a sealed canister. A drill bites 2 meters deep, coring through layers untouched since the magma ocean solidified. Tiny instruments sniff the thin exosphere, French, Swedish, Italian, Pakistani payloads all working together while the clock ticks. Every gram counts. The ascender stage has to lift off with no runway, no second chance, from a surface no human has ever stood on. On June 3rd it ignites, a miniature rocket rising straight up from the hidden hemisphere, carrying just under 2 kilograms of the most valuable dirt in the solar system. 4 days later it docks automatically with the waiting orbiter, the first fully autonomous rendezvous and docking ever performed on the far side. On June 25th, the return capsule blazes back through Earth's atmosphere and parachutes into the grasslands of Inner Mongolia. Mission duration, 53 days. Success rate, 100%. China now owns the only far-side lunar samples on planet Earth. And that is when the strange began to leak out. First hints came in quiet academic WeChat groups, then in carefully worded press conferences. The basalt fragments, those dark volcanic rocks that make up the Maria, are not behaving the way anyone predicted. On the near side, Apollo and Luna samples showed mere basalts erupting mostly between 3.8 and 3.1 billion years ago. The far side was supposed to have shut down earlier, colder, thicker crust, less melting. Instead, among the first 108 basalt clasts examined under electron microscopes in Beijing, most are comfortably 2.8 billion years old, fine, expected. But one fragment, just 0.5 millimeters across, is screaming 4.2 billion years old. That is older than almost every dated rock from the near side. It is a high aluminum, KREP-rich basalt, KREP meaning potassium, rare earth elements and phosphorus, the radioactive spice that keeps planetary interiors cooking. Finding KREP on the far side at all is weird. Finding it in lava that old is borderline heretical. Think about what that means. 4.2 billion years ago, the moon was still a hellscape, its surface a global magma ocean slowly crystallizing. The giant impact that created the South Pole-Aitken Basin happened around then, excavating so deep that mantle material was flung across half the moon. Somehow, that impact either triggered or fed massive volcanic eruptions that lasted hundreds of millions of years longer than we thought possible on the far side. The standard model said the far side should have frozen early. Chang'e 6 just handed us evidence that parts of it stayed hot, molten, alive, long after the near side had already painted its familiar dark seas. Then came the magnetic ghosts. The moon today has no global magnetic field, but these samples carry paleomagnetic memories locked into tiny grains of magnetite and ilmenite. When scientists at the Institute of Geology and Geophysics in Beijing heated and cooled the fragments in controlled magnetic fields, the grains realigned to reveal a dynamo that was still churning inside the lunar core as late as 2.8 billion years ago, maybe even 2.5. That is hundreds of millions of years longer than the best previous estimates. A dying lunar dynamo means the core was still convecting, still generating heat, still shielding the surface from the worst of the solar wind. And that shielding matters because it may explain the next surprise. Water, not lakes, not rivers, but hydroxyl and molecular water bound inside mineral crystals. Up to 140 parts per million in some glass beads, higher than many Apollo samples. The solar wind constantly implants hydrogen into the top few microns of regolith, but these deeper grains were protected by that ancient magnetic field long enough for water to diffuse inward and get trapped when the minerals crystallized. The far side, once thought bone dry, might actually be one of the wettest places on the moon in terms of bound volatiles. A few hundred grams per ton doesn't sound like much until you remember that the South Pole-Aitken Basin alone contains billions of tons of this stuff. Enough, perhaps, to fuel an entire generation of lunar rocket engines. Geochemistry is throwing more curveballs. Titanium concentrations are lower than almost every near-side mare. Magnesium to iron ratios are flipped. Plagioclase feldspar, the bright stuff that makes the highlands shine, is present in weird abundances. The mantle underneath the far side looks like it was stirred by a different spoon. Some researchers are already whispering that the giant impactor that created the basin may have delivered its own mantle material, mixing exotic chemistry into the lunar interior in ways we've never seen. Others point to the thorium and uranium maps from earlier orbiters. The far side is poor in heat-producing elements, yet somehow it kept erupting. The only way that works is if the impact itself provided the energy. A cosmic pressure cooker that kept the far side simmering long after the near side went cold. And then there are the glass beads. Billions of tiny spherules formed when micrometeorites vaporize the surface, and the vapor condenses back into perfect glass droplets. Chang'e 6 brought back colors we've never seen before: deep emerald greens, translucent amber, even a few with iridescent purple sheen. The chemistry inside them records impactors from the asteroid belt, from the outer solar system, maybe even interstellar dust that drifted through 4 billion years ago. Each bead is a time capsule of a different catastrophe. When the first scanning electron microscope images hit Chinese social media, the comments exploded, people saying they look like dragon pearls from ancient mythology. Scientists just call them priceless. All of this is from the first few grams. The bulk of the 1,935-gram haul is still sealed in nitrogen-filled containers, waiting for the big international unveiling scheduled for late 2025 and 2026. Under the rules of the Artemis Accords and the older COSPAR planetary protection agreements, China has promised to share a portion with qualified researchers worldwide. But make no mistake, Beijing now controls the only far-side sample catalog on Earth. That gives them first look, first publication, first chance to rewrite textbooks. And the timing could not be more charged. While Chang'e 6 was drilling in the dark, NASA's Artemis program was still wrestling with Starship explosions in Texas and billion-dollar overruns on SLS. China's next move is Chang'e 7 in 2026, a South Pole resource mapper, followed by Chang'e 8 in 2028, an in-situ resource utilization demonstrator that will literally try to 3D print bricks from lunar soil and extract oxygen from regolith. By 2030, they want the basic outline of the International Lunar Research Station operating at the South Pole, open to partners who play by their rules. Russia has already signed up. Brazil, Pakistan, South Africa, and the United Arab Emirates have expressed interest. Europe is debating. The United States, bound by the Wolf Amendment, is legally barred from direct bilateral cooperation unless Congress says otherwise. So yes, the samples are strange, but the geopolitics are stranger still. In the span of 5 years, China has gone from lunar newcomer to the only nation with boots, well, robotic feet, on the far side and samples in hand. The data coming out of those sealed canisters will shape lunar science for decades, and whoever controls the narrative controls the future of cislunar space. But step back from the politics for a second and just feel the weight of what happened. A machine built by human hands traveled 400,000 kilometers, landed on a part of the moon that no eye from Earth has ever seen directly, dug into soil older than any continent on our planet, and flew home with pieces of another world. And those pieces are whispering that the moon we thought we knew was only half the story. The far side kept its own history, its own volcanoes, its own magnetic heartbeat, its own water locked away in crystal cages. Every time you look up at the full moon now, remember, half of what you're seeing is a lie by omission. The real moon, the ancient, violent, water-bearing, still mysterious moon, has finally started talking, and the first words out of its mouth are not what anyone expected. The next chapter is already written in launch manifests. Chang'e 7, Chang'e 8, the ILRS, maybe even crewed missions by the mid-2030s. The far side is no longer off-limits. It is the new frontier, and the strangest discoveries are almost certainly still waiting under the regolith. So keep your eyes on the moon, because the moon is finally looking back.